Hello, welcome to ZenView Studios Lab. I'm Eric. Today we talk about repair which I couldn't find on internet. It's an Alesis powered speaker board. It has a power amp and a switching power supply inside, and we'll go about the repair. It was the switching power supply which was defective. That seemed to be a problem when those age. So I'll go over what I found on the board, and then in the second video we'll make some measurements and see if we can improve a little bit the sound and the response of those Alesis powered speakers. Hope you enjoy. If you do, please subscribe and click on the like button. Thank you. And now on to the technical stuff. So here we go. This is Alesis M1 Active speaker. It's the board that goes that's inside the speaker itself. You have the power amp, which is over here, with two outputs from those two chips. One is for the tweeter here and one for the woofer, and the power supply unit. We'll go over in detail now on the power supply unit, which was the unit which was defective, which had a problem, in fact. So, to detail this, I will take the other board, which is dismounted. This one is the one which was repaired. The resistors are different here. I've changed them. You can see a little bit better closer, maybe. So these are new. These are new here, and the condos here were changed, and this one also was changed. This was all defective. I'll go over it in detail with the other board. It's not remounted. This was tested, so that's why. Okay, so this is the same board, as you can see. Just to detail how the things work, you have the power supply, which is fed through this. There's a capacitor. You will see on the schematic. I'll detail it on the schematic again, but this is just so you have an idea how it flows. And the voltage comes through those this rectifier, and with those capacitors, these are 200 volts, if I remember. Yes, 200 volts capacitors. So they are directly on the main here, even if it's 240, because it's one side of the main each. So, and these were the resistors which had trouble. They were, in fact, what happened is they overheated, and one of the trays here was dead and was burned. So, and this capacitor also went bad. None of the rest, the electronic part was okay. The capacitors were not good anymore. This one was not good anymore, and the two resistors were not good. So if you have a power supply problem, you have to check. You have to be very careful, because there's no power going to it. But when you do run with power, you have to watch out. This is all with high voltage, so you have to be very careful what you do. Anyhow, so the main thing to know is that when the problem was lying around those resistors who overheat. The thing that might go wrong is that when they overheat, they will burn, as I said, the PC board underneath, and you might end up wanting, which is what I did. I saw the resistors were dead, so I changed the resistors, checked the capacitors and everything, and changed the capacitors. But one thing I didn't notice was that one of the traces had burned on the other side underneath here, and you couldn't see it really. And this is what you have to watch for. that underneath the condo right there, you have to take off the condo to really see that underneath this. You might not have a trace which is not making continuous thing. The way this expressed itself was that, in fact, when I powered just quickly, first one of the sides would not, after taking off the power, would not come down in voltage, meaning one of the normally when you turn off the voltage, these resistors bleed the capacitor, so eventually you'll get 0 volt if you measure the capacitors here. Actually, what happened, since I had good resistors, I had changed the resistors, but as the trace was bad, and I didn't realize that one of the capacitors wasn't bleeding. So you have, again, be very careful, even when it's powered off, because it's 200 volt caps. You have 100 volt on each one, even if it's 220, 240, 120 volts. So it's high voltage. So you have to be careful. And this is what happened. So I redid the trace. Everything came back together normal after changing just so 1, 2, 3, 4, 5, 3 caps in 2 resistors. That was all there was. Okay, so this is the deal. The problems probably are generally with this power supply. This is where it lies around, and the amp, from what I've seen on internet looking for a solution and for people having repaired this, there's not much explanation. In fact, people who have repaired the board before don't seem to explain so much what had happened to them. One thing also, when I tried this, I burned a diode when I tried to repair it, and then, so as usual, the way to go about when the board comes to you is to check all those components one by one, the major ones which come in, you know, where the the AC comes in, and see that everything is okay with the ohm meter before you change anything. You just have to go through all the step by step, and that's basic stuff. But most likely you'll have a problem with these. They really tend to overheat. This is the same age board as the other one, which was burned, so one can go bad and the other can still work. This is an example of proof, because both speakers were used the same way, just the other board burned, not this one, which gave me something to go about, which is quite good. When you have 2 boards, you can check what you ought to see, and if comparing if resistance are okay between one and the other board, and things like this. Also with the inductors and everything else, you have a better idea if everything is okay, namely also for all those parts where you might not know exactly what you ought to see directly on the pins. This is always easier when you have 2 boards to compare. Voila, that's for that. I'll go over it a little bit on the schematic, so you can see what I showed you, where it is on the schematic. But it's okay. It's fairly simple. It's not that complicated, complex story. Hope you enjoyed it. I'll go over a little bit on the schematic, and then the rest will be for the next video on the amp. So here we are. So this is the schematic. You can find it easily on internet. And so you see the AC, the power supply, comes here. That's what I explained you. The fuse that I showed you, it's here. It's this one. This might blow, obviously. I think it was blown in my unit when I got it. So I did change, that's something I forgot to tell you, I changed the fuse. Also one thing which you might consider is the the thermistor here, which protects the limits the current. I had one which was a problem. I changed it also. So the main thing, but none of this affected. I mean, even with the thermistor half cracked, it could work. The main thing, so you can see the rail comes here, and it's this big cap and this big cap, and also the smaller one here that had gone because of these resistors, which are the bleed resistors that you see on the schematic. Beware, the schematic here says 220 microfarad 35 volts. It's a 330 microfarad. That's what's on the boards, on both boards. So it's a mistake on the schematic. I don't know if the version you might find on internet will say the same, but you ought to change with 330 microfarads, 35 volts for that. As you see, all the ones which blew, I mean, which had problems, are the ones which were directly in contact with that part of the circuit where the resistor shorted. In fact, I mean, they were not they were not shorted. They were not working anymore. They weren't showing any resistance at all. And that's what I changed. That's it for what you know, what you ought to know. The other thing is obviously this story of the trace. Watch out for that. As that's what I was exposed to. I don't know if other problem might be on other power supplies, but anyway, none of the switching parts in the regulator had problems. All the parts were good. So thanks to that, it was just some passive components. That's it, and you can find this schematic pretty easily looking for Alesis service manual. Voila, hope you enjoyed. One more thing, there's something I said which was inaccurate about those resistors. I forgot since I repaired it. The resistance were not open. They were just not the wrong value. Here you can see 38K. Both of them somewhere around those values. They had changed. That's what happened to them. See, 39K. They're supposed to be 47Ks. So this was what happened to them, and obviously didn't go well. But that's the story. So they're not open or shorted. They were just values. The values had migrated. It changed. It went from 47 to 39Ks. So more current, more overheating. Voila. Hello. If you like this video, please don't forget to subscribe. This way you'll get notices of new repairs and new vids coming out. Thank you for watching.